Welcome to Nugget 227 with Steve and Dana Groman, and this will be question number 3. We have a variety of questions from high school and middle school students, and we are answering those. The first one was talking about the age of the earth and what does the Bible say, and that was Nugget 225. In Nugget 226, we answered the question, why do they say that dinosaur fossils are millions of years old? And this is question number 3, and I have to say that this is the question that you have been asked the most for decades. This isn't exactly how the question is always posed to you, but the question of carbon-14, carbon dating is always asked. In this particular case, the student asked, I don't understand carbon dating. What makes them think a fossil is 1.3 million years old? Okay, let's answer that.
The thing of it is, we have been so conditioned to believe what the evolutionists teach, what they say. Of course, carbon dating is one of them. Everybody sees that or hears that word, or they naturally think that proves evolution. That proves it somehow. And so we must be wrong. And that is just simply not true. That's not the way it goes at all. Willard Libby invented the carbon-14 decay method, 1956, University of Chicago. Willard Libby was born in 1908 in Colorado, and he died in 1980 in California. But he was an American chemist who developed the whole radiocarbon dating method. And it's been used by archaeologists and anthropologists and earth scientists for a number of years, really since then. He was very brilliant in what he did, but he was also honest. He was a little more honest than I think a lot of the more modern day types are. Everybody has seen some kind of video where there's a couple of guys with a box, and that thing is usually connected to a little wand and a coily wire, and you wave it across an item, and you hear the click, 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 click on the machine. And what it's doing is registering decay particles from the alpha decay particles of the radioactive element, whatever the case may be. I actually have a gamma detector watch that is, it's kind of neat because it does the same thing. These things, when the alpha decay particles of an item decay off of there, it registers as a click on the device. You can count the number of clicks based on the element that it is, and you can find out basically how long it's been going.
Willard Libby did his work at the University of Chicago, and we were fortunate enough to visit the once fabulous city of Chicago. Who knows what shape it is in these days, but a couple of years ago, we had a fabulous day in Chicago, and one of the places that we did go was the campus of the University of Chicago to see a couple of things, a Frank Lloyd Wright home, and just to walk around the campus. We found this sign that had the historic laboratory school campus. So it was a beautiful day, as you can see, and it was all kind of cool.
A lot of history there.
Back to Willard Libby.
Willard Libby said that his carbon dating method is only good for really 2,000 years maximum, and that's only true if. All throughout that book, he repeatedly says if, then. There are a number of factors that are needed and required for the if-thens to work out, and he knew full well that the if-thens didn't work for them. If the cosmic radiation has remained at present intensity for 20 or 30,000 years, well, there's no way to know that because nobody knows anything about those kind of times, even if you believe it. So the fact is, they're skewed. The tables are skewed, the curves are skewed, but they have to have them to do something.
Dating the magnetic field that you just mentioned, it says accurate measurements taken for over 160 years have shown the strength of the Earth's magnetic field to be declining. Well, that's all great, but that's 160 years, so we can't extrapolate back 20,000, 30,000 years. That is just pure assumption.
All those dating methods are based on assumption. That's how they use it. There are many things that can affect the decay rates of anything.
Well, as we go through these slides, we're not going to sit here and read these. If you want to stop the video and read them, as you read them, you can see that it's all really based on assumptions and presumptions. When they talk about this, even the 5,730 year half-life of carbon-14, there is no way to test any of this. It is all assumptions. What they are assuming is based on an assumption, which is just illogical at best. They have been looking at certain things for 160 years, and here Willard Libby designs this in the mid-50s.
Well, like it says here, the half-life of carbon-14 that came up with 5,730 years. Nobody's watched it that long. They've only watched it a short period of time, but they've projected those dates out to be that far.
I guess my point is with these statements and these sections that we've pulled from like Encyclopedia Britannica, it can all sound good, but when you realize the time frames cannot be verified, in some of the cases, we know as creationists, the time frames don't even exist and never did exist, so it can't be. And like this one says, by measuring the remaining activity to determine the time elapsed since death if this occurred during the period between approximately 500 and 30,000 years ago. That's what they're saying, that they could test something if it died between that. Well, we know that there's no 30,000 years ago.
Right.
That's a big span to say that you can test something over. Maybe something that's 500 years old. They might be able to, because you can pull in other factors to confirm what you're testing.
Yeah, confirm the assumptions of it, too.
If you find papyrus or just different archaeological things, you know what civilization this came from, and you know from other factors when that existed, and you can confirm it. But to independently come up with some numbers based on this, it just doesn't make sense.
When a plant is alive, it takes in carbon-14 into the leaves and the stems, and it absorbs this stuff in. After it dies, the carbon-14 decays into nitrogen-14 because it's no longer pulling more in. They say they can measure the amounts of both carbon-14 and carbon-12, and since they know the time it takes for the isotope to decay, they can calculate when the plant died. That's not necessarily true, because what if something happened in the middle of that time frame that caused the scale to be skewed, which is quite often what happens. They say there is a known half-life of everything. This just happen to be talking about carbon, but they say everything can undergo about 7 half-lives before there's just really nothing left to measure. And like I was mentioning earlier, 5,730 years, they say, is the known half-life of the carbon decay method. Well, that means if you go out in time 5,730 years, half of it is already gone. But what if there was no 5,730 years of decay time? We don't know when it was. They could believe it. But they call this the curve of knowns when they have these nice graphs, nice charts, but it's based on assumption. You always keep that in mind.
They're probably really not knowns.
No, they're assumptions. They have all kinds of things they've plotted out, and yes, there is some consistency to some of this stuff, but it does not necessarily mean that it's true. Because like this curve shows, that if you go out from today, or the bottom right of the chart as you look at it, and you go out 5,730 years and then go up and hit the curve, you're going to hit that curve at about 8 clicks. It's going to be across that 8 mark. Carbon-14 has 16 clicks per minute per gram, so 5,730 years, half-life, now you've gone down half of it. It'll be a smaller number of clicks. But again, that's all based on assumptions,
Well, here's my example. They can measure these items that are relatively recent, like tree rings and Bible parchment and these redwoods. As it states, Willard Libby himself says only good for 2,000 years. And that's not to say that they haven't, quote, improved it now. So we're not just saying that his methods are necessarily what they're still doing. But the point is, it wasn't ever designed to extrapolate a long time ago. But they take it out to 20,000 years when we can't prove that.
No.
Is the bottom line. It is not science. Once you can't test it and know for sure and you start assuming, then you've crossed over.
If we walk in a room and there's a candle on the table burning, and I ask you, when did the candle get lit? There's absolutely no way to tell. But we could apply some science to it. We could actually slap a yardstick up alongside of it. We could film it, and we can show scientifically that the candle is burning at 1 inch per hour. We can measure to the top of it and watch it for an hour. We can find out what the rating is. So now we have some accurate scientific measurements. So when was it lit? See, we still don't know, because there's still a lot of assumptions that have to be factored in. The candle appears to be tapered. Maybe it used to burn slower. Maybe it used to burn faster. Maybe there was more wind in the room. Maybe there was less wind in the room. We don't know. Maybe there's more oxygen. Maybe there's less. You have to assume all of these things at the starting point. What if those assumptions are wrong? Yes, you can measure something now, but that's not to say it's always been that way. Maybe that candle was 14 inches tall and it just got lit. Maybe that candle was 14 feet tall and it's been burning a long time. We don't know. In order to come to a conclusion, you have to assume some stuff.
Well, there is a lot to this topic, but I hope that we have presented some information to let you see that it's just not as airtight of a case as they want to presume. And here's a chart with some radioactive isotopes and their half-lives. Just look at these numbers.
Rubidium strontium has a half-life of 48.8 billion years. So it has a half-life, a time frame that's absolutely impossible to verify.
And again, here they show the carbon-14 and the nitrogen-14 of the half-life of 5,715 years. Yet, as we have mentioned, they will use carbon-14 method for years, much longer than that. But I hope this answers your question and piques your curiosity and opens your eyes about the strength of the carbon-14 method.
We just don't ever want to just arbitrarily believe something because
Right.
somebody says so.
Exactly. All right, well, thank you.